Hey everyone, and welcome to this explainer. I am so incredibly thrilled to have you here today. We're going to be diving head first into one of the most literally awe-inspiring displays of raw geological power anywhere on Earth, the Yellowstone volcanic system. So, if you're the kind of person who loves discovering how our dynamic planet actually operates deep beneath the surface, well, you are absolutely in the right place.
Okay, let's just get right to it. Because if you spend, any time at all online, you have definitely seen these sensational headlines, the terrifying rumors, the whole "is America's most famous national park actually a ticking time bomb ready to wipe out the continent" narrative. Today, we're putting all that clickbait aside. We're going to look strictly at the real established science to figure out what is actually happening right now beneath those famous geysers.
Look, the sheer cinematic scale of Yellowstone's history is quite literally written right there in the rocks. It's a story that has been millions of years in the making. I mean, this volcanic system has fundamentally reshaped the entire topography of the western United States through these massive caldera-forming events. We're talking about events that blasted continental-scale ash all across North America. Let's move to and see how this builds. The geological record reveals three major catastrophic cycles here. The first one went off roughly 2.08 million years ago, and it expelled a staggering 2,500 cubic kilometers of volcanic material. To put that into perspective, that is one of the largest known eruptions on Earth, period. That was followed by massive events 1.3 million years ago, and again 640,000 years ago. These weren't just your standard eruptions, these were totally landscape-altering cataclysms.
Anatomy of a supervolcano. So what exactly is powering all this? Let's peel back the surface, journey way down beneath the bubbling mud pots and hot springs, and look at the true anatomy of this subterranean monster.
To really grasp the scale of the magma system beneath Yellowstone, consider this jaw-dropping statistic. Scientists recently discovered a much deeper, vastly larger magma reservoir sitting right beneath the previously known one. The volume of hot rock in this newly identified deep reservoir, it's enough to fill the Grand Canyon. Wait for it, 11.2 times over. Crazy, right? Now, what's really interesting about this slide is how modern seismology has completely corrected our old assumptions. We used to think there was just this one giant cavernous tank of magma down there. Actually, scratch that. It's a dual reservoir system. You have an upper chamber sitting about 3 to 9 miles down, filled with high silica rhyolite. And then beneath that, stretching 12 to 28 miles deep, is this colossal lower reservoir made of low silica basalt. But here is where public perception gets it completely wrong. Yellowstone is not resting on some sloshing subterranean ocean of liquid fire. That's just movie stuff. Instead, scientists define this system as magmatic mush. It's basically a complex, mostly solid, sponge-like mixture of rock and crystals, interspersed with these little pockets of liquid silicate melt.
So how do we know this with such an incredible detail? Well, researchers from the University of Utah and the USGS didn't just sit around waiting for random earthquakes to echo through the ground. They actively mapped the plumbing. They deployed an array of 650 portable geophones and brought in these heavy vibroseismic trucks. These trucks literally thump the ground to generate artificial seismic waves. It's like they basically performed a giant high-resolution MRI on the Earth's crust, bringing the whole magma chamber into incredibly sharp focus.
The global impact. Even though it is mostly solid mush right now, we still have to ask the big what if, right? Let's explore the chilling reality of what a global impact would actually look like. The true hallmark of a supereruption is this terrifying phenomenon known as an umbrella cloud. Unlike smaller eruptions that just kind of get blown sideways by the prevailing wind, an umbrella cloud is so massive and so powerful that it literally drives its own expansion. It spreads radially in all directions. Scientific modeling show that within 500 kilometers, ash could pile up meters deep. But it wouldn't stop there. It would push millimeters of ash all the way out to New York City and Los Angeles. The cascading consequences of an event like that would be felt instantly worldwide. I mean, the microscopic shards of volcanic glass in the ash, that would ground aviation across the entire northern hemisphere. No flights. We would see massive agricultural failures in the Midwest just from ash burial and altered soil pH. Plus, injecting millions of tons of sulfur dioxide into the stratosphere would trigger a volcanic winter. We're talking about cooling the global surface by 6 to 8 degrees Fahrenheit for potentially an entire decade. In the economic shockwave, completely unprecedented. Hypothetical modeling by risk assessment groups estimates a global GDP loss of $1.6 trillion over 5 years. and that's primarily driven by the severe, unavoidable disruptions to global supply chains and agriculture.
Fact versus fiction. Okay, let's take a deep breath after looking at those scary numbers because it is time to shift gears. Let's confidently dismantle the internet hysteria and look at fact versus fiction using cold, hard science.
You have definitely heard the myth. Yellowstone is overdue for an eruption. Guys, this is completely false. Volcanoes just do not operate on schedules or calendars. Trying to calculate a recurrence interval based on just 2 data points from millions of years ago is scientifically meaningless. Eruptions are dictated by the physical state of the magma, not the turning of calendar pages.
So, the crucial point is this. For a massive eruption to occur, you need a vast amount of highly pressurized liquid melt. But as we just learned, the upper reservoir is currently around 91% solid rock and crystals, with only about 9% liquid melt. It simply lacks the eruptive capacity right now. It is way too solid to trigger a massive supereruption.
And what about those viral videos claiming the animals know something we don't and are fleeing the park en masse? As the US Geological Survey bluntly points out, this is total hogwash. These rumors pop up literally every single year. The videos are either misdated, filmed in totally different states, or they just show totally normal seasonal wildlife migrations, like bison and elk moving to lower elevations for the winter. The animals are absolutely not evacuated.
Monitoring the beast. So if we aren't relying on running bison for our early warning system, how do we keep an eye on Yellowstone? Well, we rely on a massive, highly advanced array of technology.
The Yellowstone Volcano Observatory acts as the ultimate pulse tracker for the system. It's one of the most heavily instrumented volcanic areas on the planet. They use networks of seismometers to track tiny earthquakes that indicate fluid migration. They've got continuous GPS stations measuring millimeter-scale ground swelling, and gas sensors constantly checking for magma degassing deep underground. If Yellowstone were ever waking up for a major eruption, the warning signs would be massive, and we'd see them years or even decades in advance.
Because of all this incredible monitoring, scientists can actually calculate the real risk. The annual probability of a supereruption occurring today is roughly 1 in 700,000. It is a highly comforting perspective when you realize just how incredibly unlikely an eruption is in our lifetimes.
Which brings us to a very practical question, doesn't it? If a supereruption is essentially off the table for now, what is the most likely volcanic hazard we might actually see at Yellowstone today?
The reality is much less apocalyptic. The actual hazards scientists expect are hydrothermal explosions, basically localized rock-hurling geyser eruptions that form craters just a few meters across, or potentially very slow-moving minor lava flows. These are the true documented hazards, not cataclysmic, continent-destroying explosions.
We have covered the explosive history, the incredible subterranean architecture, and the advanced science that keeps us safe. The takeaway here is incredibly clear. Yellowstone is not a ticking time bomb. It is a closely monitored marvel of nature. It's a reminder of the awe-inspiring dynamic geological forces that shape our planet. So let's always remember to respect the science over the sensation. And it makes you think, if scientists have uncovered all of this beneath just one national park, what other sleeping titans might be hiding right beneath our feet, waiting to be discovered? Thank you so much for joining me on this explainer, and stay curious.